All right. It's still Saturday. Now it's afternoon. And we're going to complete Summer 7.7. That's seventh grade, Chapter 7. And we're dealing with probabilities or statistics. I like probabilities a lot. That was one of my more favorite courses that I took in college. The probability of an event is 0.28, or we'd say 28% successful. Describe the likelihood of the event. Well, it's 28 times successful, and the counter of that would be 72 times unsuccessful. So if we want to describe the likelihood, well, if it's only successful 28 out of 100 times, we would say that that is unlikely. It's not impossible. It's not equal, that's for sure. And it definitely isn't likely or certain. You randomly draw. Let's increase that view here. Let's zoom that out a little bit. There we go. You randomly draw a marble from a bag, record its color, and then replace it. You draw a green marble 41 out of 50 times. What is the experimental probability that the next marble will be green? Write your answer as a fraction, decimal, or percent. Well, that's going to be 41 successful times out of 50 possible times. So there's my fraction. You could say it's 82%, or you can say it's 0.82. Any of those answers work as the answer. There are 5 yellow marbles and 6 blue marbles in a bag. You randomly choose one of the marbles. What is the theoretical probability of choosing a yellow marble? Well, there are 5 out of 11 marbles, 5 plus the 6 in the bag. So there are 5 successful outcomes out of 11 possible outcomes. And that's what my fraction's always going to be. It says as a fraction in simplest form, so 5/11 is correct. Use the table to predict the number of times you will spin 6 when you spin the spinner 100 times. So 6 was spun 9 out of, what's that going to be? So the probability is 9 out of 14. That's 14, 25. That is 32. That is 41, that's 50. So 9 out of 50, which equates to, out of 100 times, would be 18 out of 100. So how many times would we predict a 6 would come up? It would come up 18 times. Find the total number of possible outcomes when you select one color of wallpaper and one color of carpet. So wallpaper has 2 choices, and we're going to multiply it by the number of choices of carpet, which is also 2. So there are 4 possible outcomes. That's a really fun, very, very neat way of counting combinations is really what it is. And you just multiply the number of choices. It's like when you go to McDonald's and you have choices for a drink, a burger, and a dessert. You're just going to multiply the number of selections per category. You roll a 6-sided number cube and you flip a coin. What is the probability of rolling a number less than 1 on a 6-sided? Is going to be 1 out of 6. And a flipping tails, well, that's 1 out of 2. So that becomes 1/12. Okay, so the probability is 1/12. 1 out of every 12 times you'll flip. There are 12 different combinations, and there's only one number less than 2 and 1 tail. So that's that. This is an interesting one. So let's read it. Each day for the next 4 days, there is a 20% chance of a thunderstorm. Use the simulation shown where the digits 1 and 2 represent days with a thunderstorm to estimate the probability of a thunderstorm on at least 2 of the next 4 days. Round your answer to the nearest 1/10% if necessary. Okay, well, I didn't really understand this, first of all. So I struggled with this for about 10 minutes. I was looking at this and I see a 2 there. So that day it rained. I see a 1 here. That day it rained here, it rained here. It did not, it did not, did, because of the 2, did not, 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 did. And I counted them all up and I ended up with 17 out of 30. But that's not how we were supposed to do this. So the answer was not 17 out of 30. So I was completely wrong. Then I'm like, okay, well, let's include the double days, right? Here's 2. Here it rained twice. In this day, it rained twice. I thought each one was a single day. And that was where my misinterpretation of it. Well, this is where we can use technology. Okay, so what I did was I took this question and I put it into Gemini and I pasted it in there. I said, can you help me with this problem? So the first thing, it says estimate the problem at least 2 days. So it just reiterated what it was looking. Each 4-digit number represents one 4-day trial. Boom, right there. I didn't see it in that way. I didn't understand that those were the 4 days. So it rained this first day, it didn't rain, and it didn't rain. So each one was a 4-day thing. Okay, once I figured that out, I was like, okay, when does it rain 2 out of the 4? Well, that's not a situation. One day it only rained 1 of the 4, none of the 4, 1 of the 4. And so I went and looked to find how many situations of the 30 where it rained twice. Well, it rained twice on this day. It rained twice on, this day. And it rained twice on, there's one more day that rained twice. Where are we? Where is it? There's one more. I know there's 3. My eyeballs are not working. Okay, right there, right next to it. Hello. So it rained 3 out of the 30 simulations. So that equates to a 10% chance of it raining. That was way, way easier than it looked to be. And here they go analyzing. It rained. And so it talks about it and it goes through and it sees that there are only 3 successful trials out of 30 total trials. So the estimated probability. That's how we can use. And then if you didn't understand it, you can type, hey, can you explain it further if we didn't understand? And then the cool thing is it will. Why use random numbers? Breaking down the 4-day trial. No storm. See, now it says no storm. And it says that there was a storm, but only one of the storm. Oh, there's storm. So example B shows when there were 2 storms. And then it just can go into further. And if you want more, you can do more. So that's a cool way of using technology, not to just give you the answer, but to help you with the comprehension. You choose 2 different movies on a list at random. Out of 10 movies on the list, 6 are action movies. The first movie you choose is an action movie. What is the probability that the second movie is also? Well, if we pick a movie, now we don't have 10 movies, now we have 9. And if the first one that we picked was an action, so now we're left with 5 action movies out of 9 on the list. So my probability is 5/9 to pick one. A claw arcade machine contains stuffed animals and mystery boxes. There are 84 items in the machine. Winning a stuffed animal has twice as many favorable outcomes as winning a mystery box. So it's going to be the probability of the mystery box plus, or the number of mystery box plus stuffed animal. And if we had to equate it, we don't know how many mystery, and we know stuff is going to be twice as likely as the mystery. And we know that there are 84 stuffed animals in there. So we do 3x equals 84 and divide by 3. X equals 28. So X represents the mystery boxes. So that would be 28 mystery boxes. And then we are twice as likely. So that's going to be 56. And notice that equals 84. So 56 stuffed animals, because stuffed animals is twice as many favorable outcomes. So we're always going to be able to read that and understand we're going to have more stuffed animals than mystery boxes. You roll a number cube and record an odd number 8 times in a row. As the number of times you roll an odd number increases, what happens to the theoretical probability that you roll an even number? Important word here is theoretical. It's always going to be the same. It's not going to change. Theoretical probability does not change. Odds are going to happen half of the time, every single time. Even if you have rolled 100 odds in a row, rolling an odd number on the next roll is still going to be 50%. It's crazy. It's fun. Cool. Love that question. The tiles shown are placed in a bag. You randomly select one of the tiles, return it to the bag, and randomly select another tile. What is the probability that the first number divided by the second number is less than 0? Well, each time you draw it, it's going to be 50%. So it's 50% of the time, because there's 2 numbers that are less than 0, 2 greater than 0. So it's always going to be 50%, because you're either going to pick this, or this, and only 2 of them would give you less, and 2 of them would give you more. So I think that number is less than 0. Well, let's think about that a little bit further. So let's do the combinations. Well, yeah, you have 4, so you have 16 combinations. So you have -2, -2, you have -2, -1, you have -2, 2, you have -2, 1. That's going to give you -4, that's going to give you -3, that's going to give you 0, that's going to give you -1. Second number, what is the probability of the first number divided by the second number is less than 0? The number divided by the second number is less than 0. Okay, well, let's do the math on that. Sorry, I was thinking of it differently again. So if we divide, that's equal to 1. That's equal to 1. That's equal to 2. That's equal to -1. This is equal to -2. So it's still 50%. So it doesn't matter. You'll get the same percent. So it's 50%, because half of them are greater than 0, half of them are less than 0. And it doesn't matter if you do -1, 2, or 1, you're still going to get those same combinations, just flipping it. So it's 50%. All right, these are the answers. The probability of event, yep, unlikely. Randomly draw a marble, 41 out of 50. Yep, they gave a fraction. I would have liked to have seen, if you say you can write it as a fraction, decimal, or percent, I'd like to see those answers. 82% or 0.82. 5 yellow marbles out of 11 total marbles. Number spun is 18, so that's 9 out of 50. So out of 100 times would be 9 times 2 is 18. There are 4 possible: green, orange, green, red, purple, orange, purple, red. Those are the 4 different possible outcomes. The probability, 6 number coin. Yeah, so it's 1 of 6 times 1 of 2, which is 1/12. And then we know about 7 is 10%. 8, 2 different movies. Yep. So when we remove one of the action movies, you also remove one of the lists. So it goes from 5/9. 28 mystery boxes and twice as many. So 56 stuffed animals. Theoretical probability doesn't change, because you're not changing the successful outcomes and the possible outcomes. And the tile bag was 50. All right. Good luck with this.